So the really clever part of this homemade jointer is the parallelogram adjustment mechanism, which adjusts with the crank here. Now, when I built this jointer, I didn't take enough video of how I actually built that mechanism. So in this video, I'm going to build that mechanism again just to show you how. I started with the paper templates for the parallelogram links, and I cut those out and pasted them onto a scrap piece of oak. Then I punched divot holes for where the holes are going to be, and next I cut the whole piece out on the bandsaw. So before I drill any holes in my wooden pattern, I tested a couple of drills. So I drilled this hole with this drill, and this hole with another drill, because the drills don't always drill holes of the same size. So this is my 3/8 inch round rod, which I just bought at the Home Depot. And that needs to fit tightly in one of those holes. So this hole here, I actually have a fair bit of play. So I know I shouldn't be using this drill. The drill is too large. But in this hole here, it actually fits quite tight with very little play. You actually have to kind of force it in there a little bit. So that's actually a really good fit, because I don't want my mechanism to have any play. And if there's a little bit of friction, that's okay, because the adjustment screw will give the whole mechanism a tremendous amount of mechanical advantage. Now drilling the holes in my pattern. The brad point drill I'm using has actually got a little bit of a wobble to it, but that divot I placed in the wood nicely lines up with the drill, so even though the drill wobbles a bit, I get a really accurate hole. So the plywood I'm using for my parallelogram mechanism is this Baltic birch plywood, which has layers of birch hardwood throughout, which makes it much tougher and more precise than other plywood. And I'm just going to take this pattern here and I'm going to screw it down on this piece of plywood. So now with this firmly attached, I'm going to use these holes as guides for where to drill in the holes, and that will make them very consistent from piece to piece, because I'll always be drilling through these holes. I added a chamfer to the ends of the shafts that I'm using, just to make it easier to get them into the holes. So this is an important fit check to make sure my parallelogram links are all identical. So if they're all the same, I should be able to put all these shafts through all of them at the same time and not have things jam up. Now, these all fit pretty tight to begin with, but let's see, that goes in, yeah. So that's a really tight fit with those all together, and that's good because I don't want any play in there, and they line up well enough to get the shaft through all of them. The next thing I did is cut the long rails for my parallelogram mechanism. These are the parts that attach to the frame and to the table. So the next thing I need to do is to make sure that the rails that tie the links together will also have the holes drilled very, very precisely. It's no good to have the links precise if the rails that connect them together are inaccurate. So I made another template for drilling these things, which is based on these things here. So you can see there's the hole right there, and it hooks over the end of the rail, and it's got the holes in the right position, and that's really the only thing that is really critical. So I can clamp this over one of these rails and then use that to drill the holes. So when I drill these holes through here, I have to make sure they're absolutely perpendicular both in this direction and in this direction. And to make sure this block is vertical on here, I clamped a block of wood to the side, which will keep it vertical. I wanted to originally use a drill press vise to hold it nice and precisely, but I found when these jaws clamp, they tilt the workpiece just a tiny little bit. So having prepared all the parts for my parallelogram mechanism, it's time to put it together. I made these spacers to go in between to hold everything at the right distance, and that'll make everything else much easier to put together. I ran into some minor problems getting that bottom rail in there. The alignment wasn't as good as I had hoped, so I had to use a hammer to get it all in. The bar clamp comes in really handy for squeezing those rails on. So here's most of the parallelogram mechanism. Before I attach these rails here, I have to mount the whole thing in the jointer frame. So here's the beginning of the jointer frame, and these rails here butt up right against here, and so now I can screw that in there. Now this little hole here is really important for the depth adjustment, because the table is going to attach to this rail using some pieces of threaded rod sticking out on here, and on here goes the nut and a washer, and then that, when it's on here, that sticks out a little bit on the bottom here, so when the jointer is adjusted all the way down, that nut has a place to go. So here's my infeed table. Now I have to say, I'm not actually building another jointer, I'm just demonstrating the techniques. So this is not the thickness and grade of plywood I would use for an actual infeed table. But to show how it goes, here's the cavities cut for this part of the links, which sticks up from here. So that fits nicely on top of the ends of those links. The tricky part is I need to have some bits of threaded rod sticking out from the bottom here that goes exactly into these holes. And I don't have enough faith that everything is super accurately enough that if I measure that these would line up just right. So there's different ways of marking where these holes should go. So what I could use is these little dowel center things here. So you put these in a hole, then you push the table on top, and it'll leave a little point right where the dowel hole is supposed to go. But I only have 2 of these, so I can't use those. The other thing I could use is just to put the screw in there and whack it on there, and it'd be easy enough to figure out where the center of that would be. But what I'm going to do instead is I'm just going to use some little pieces of some little pegs. I didn't have any 1/4-inch dowel handy, so I just made some pegs. And I'll move that table all the way down, and I need a spacer underneath here. So now I'm going to put 4 of these in here. So I've marked exactly where this table needs to go. Just give it a good whack to mark where those holes need to go. So now I need to get a piece of threaded rod threaded into this undersized hole in the wood, and these threads, these machine screw threads, will actually hold in the wood just fine, especially because there's so many of them. Now last time I built the jointer, I just put a bolt in there, and after I screwed it in I cut off the head. But this time I'm going to use some pieces of threaded rod, so I jammed 2 nuts tightly against each other on the end of the threaded rod, and this piece of wood here is a guide just to make sure I get it into the hole straight. So now I can just put a nut driver on here and turn that in like a wood screw. Now let's fit that on, and I should point out again, if I was building an actual jointer, I would be using much better quality plywood than this stuff. So last time I was building a jointer, I was using T-nuts like this, and they fit into a bigger hole in here, and those were incredibly difficult to get on. But with a longer stud sticking out here, and then just putting a washer in here, and then a screw on top of that, it's actually much easier to get these on. So that's how to build the parallelogram height adjustment mechanism for the homemade jointer. This is as far as I'm going to take this one because I only built this to demonstrate the technique and get more video. For more on building the jointer, I have some videos about how I built my other jointer.